So next up on this range of 10 to 100 kilograms is driving in a traffic jam, a congested commute by car. It's going to be 22 kilograms CO2 equivalent for a 5-mile ride if it's crawling each way in an average car. Obviously, what kind of car you drive is going to make a difference. Every working day for a year would be 4.8 tons CO2 equivalent more than flying from Los Angeles to Barcelona and back. LA to Barcelona and back, that's a very long flight. Congested drive can cause 3 times the emissions of the same drive on a clear road. This is obviously very relevant because now every year you get ratings of which place has the worst traffic congestion and the longest commutes and so on. But what is not usually appreciated is what happens when you yourself are participating in a traffic jam. You have effects that are not very intuitive. For example, if your journey is congested, by choosing to do it, you cause about 3 times more emissions than you might expect. Okay, so it's not just that your car is going slow and burning inefficiently and producing emissions. The queuing theory logic also works for the time that gets wasted. If you make the assumption that the journey is many times longer than it would be if there were no traffic, then the time you waste in the line is about equal to the sum of the extra time you make everyone else waste. So you are not only participating and wasting your time, you are also affecting the travel time of others who are in the traffic jam. Of course, the same logic applies to them as well, so it's not just you, it's anybody who's in a traffic jam. Sometimes you may have no choice, but nonetheless, okay. In other words, the hassle and anguish that you experience is equal to the hassle and anguish that you inflict. So when deciding whether to drive through a busy area at rush hour, picture your own pain and double it. Okay, that's how you may want to avoid rush hours. Okay. Now let's say you're just wanting to rest in a hotel for vacation or whatever reason. A night in hotel can cause 3 kilograms CO2 equivalent if it is a low carbon scenario, 24 kilograms CO2 equivalent for $100 spent on dinner, drinks, bed and breakfast in a hotel with average eco credentials. Can jump to 60 kilograms CO2 equivalent if you're in a high carbon scenario, let's say a luxury hotel where you are not using the towel more than once, multiple towels per day, changing sheets, heated swimming pool, outdoors with heating or cooling and so on and so forth. So what I tend to always worry about is that when you go to hotels now, it's very common to say keep this card on the bed if you want sheets changed, otherwise we will not change the sheets and the towels. Okay, great. Typically I would be very eco-friendly and not ask for a sheet change other than every few days, depending on how long I stay there. Same with towels. But I always wonder, the money that I'm saving on the laundry is probably going into the profit of the hotel. And what are the owners of the hotel doing with that money I saved them? Are they being eco-friendly, or are they just using my carbon offset for their good life? So this is kind of a free riding that we all worry about, right? So if you take a 42 million ton footprint of the UK's hotels, pubs and catering industry per year, you are going to add up to this kind of contribution. Food is 23%, drinks 22%, electricity, gas and other 37%. So obviously the whole industry of food, restaurants, bars and hotels together are having a significant carbon footprint, but it's us who are using it for whatever reason. So when it comes to free riding, I like this work by Bill Nordhaus, who wrote the book Climate Casino, which won the Nobel Prize for Economics a couple of years ago. I think he shared with somebody else, but nonetheless, let's go through his arguments on why the Kyoto Protocol failed and how actually one can make these things work. This is mostly about so-called common goods. We are talking about carbon footprint because we are affecting climate, which is shared by everybody: atmosphere, water, ocean, land, and so on, right? So we are talking about common goods and shared responsibilities, and it's fair to say that all the negotiations that have gone on have not made a dent in the emissions at all. We are on business as usual scenario if you look at the carbon emissions, and things like the financial crisis and COVID make a small dent, and then we are right back to a very large increase with about 4 ppm increase per year, right? So this article by him, which is a summary of Climate Casino and several other works, is arguing for a so-called climate club. There is plenty of evidence that shows that peer pressure works in terms of reducing our impact on the environment. So climate club is kind of where you join and you get penalized if you don't join, and it puts pressure because there is a price for carbon. So in brief, the club is an agreement by participating countries to undertake harmonized emissions reductions. The agreement envisioned here centers on an international target carbon price that is the focal provision of an international agreement. For example, countries might agree that each country will implement policies that produce a minimum domestic carbon price of $25 per ton of CO2. There are other ideas like social cost of carbon and so on, and how to compute them, etc. But here let's just do some scenarios. Countries could meet the international target price requirement using whatever mechanism they choose: carbon tax, cap and trade, or a combination of them. So this is what you would call market-based policies. Not everybody agrees with it, but here we are. A key part of the club mechanism, and the major difference from all current proposals to bring about global reductions in emissions, is that non-participants are penalized. The penalty suggested here is uniform percentage of tariffs, uniform percentage tariffs on the imports of non-participants into the club region. So if you don't want to join the club and if you want to sell things, you will pay a tariff for exporting your carbon. Okay, calculations suggest that a relatively low penalty tariff rate will induce widespread participation among countries as long as the target carbon price is less than $50 per ton. So obviously there are considerations on what makes these things acceptable and so on. So it's done using a model called CDICE, Coalition DICE. DICE was the original Bill Nordhaus model used in the Climate Casino, and these things are complicated, but I'll just try to explain so that you get a sense. Here is the number of participating regions, goes from 0 to 15, and there are a number of I think 11 bars in this each target price of $12.50 per ton, $25.50, and $100, and you can see the significant change in the number of participants. And here are the tariff rates as a percentage of target price. So this and figure 2 have the following structure. The 4 sets of bars are the model results for 4 different international target carbon prices, so 1250 to 100, running from left to right as shown at the bottom. 11 bars within each set are the penalty tariff rates, so we go from 0 to 10. You can see the colors here. 0% to 10%. Note that each set has 0 participants for a 0% tariff. If there is no penalty, then obviously nobody cares. The vertical scale here is the number of participants. These results are based on the author's CDICE, Coalition DICE model. So the surprising result is that when the price is below $50, the number of participants is participating regions is high, even for a small tariff rate. So people prefer to join such a club even when the tariff rate is low. In other words, they don't say, I will just pay the tariff and stay out of the club. Okay, so they see it as a benefit to be part of the club and participate in the overall carbon reduction even when the tariff rates are relatively low. But when you go to a carbon price that's high, like 100, then you can see that the number of participating regions drops even if the tariff rate is high. They say we are just not going to pay that much carbon price, okay? And globally averaged global carbon price by target carbon price and tariff rates look like this. This graph shows the global weighted average carbon price for each regime. Weights are actual 2011 industrial CO2 emissions. The far left bars for each set is the non-cooperative carbon price. So if that means you in the game change theory, it's just that nobody is cooperating, and you end up with a price when that is on the far left when nobody is participating. So here again, global average shows that at low prices, the global average carbon price attracts large participation even for a small tariff rate, but as the target price goes up, global average carbon price and the tariff rates can go up as well. So obviously I'm not an expert in this, so I'm just including this to say that free riding is something that we have to worry about when we are talking about common goods. I don't know if restaurants, bars and hotels can be considered as common goods, but these are services used by people, and the prices and profitability and behavior within the hotel, for example, how many sheets you use, how many towels you want changed, etc., has some room for choice. Often there are financial incentives. If you don't change your towel, you'll get a free coupon for a drink, and so on. So there are various combinations being tried to bring about behavioral change to reduce your own carbon footprint when you are in a place like a hotel. And there are plenty of evidences that people use more water, more toilet paper in a public place than at home, and so on and so forth. So there is that free riding that is kind of always associated with human behavior. So the question is, how do we consider carbon footprint for ourselves, what we do about it by ourselves, and what are the mechanisms by which common goods can be protected at various scales, like regional scales with these the DICE model that we saw, or individual behaviors in a hotel by offering incentives and penalties, okay, norms and punishments. That's kind of what Elinor Ostrom had also suggested in terms of managing common goods, that they can be managed to avoid tragedies of commons by having norms and punishments. I didn't say what tragedies of commons are, but I have podcasts elsewhere that you can look up. It's how we share common resources or common goods. Okay.